So I've created a few new things since the last example, and I've got a fully working prototype now. So first thing I've developed is this create testdb.sh. So this is basically going to automate the creation of a simple database with all of the test assets that we've got. So if you remember, what we've got in our folder here is the test data, where I built up all of the different elements that I exported and so on. So here I've got the current SQL that we use to create the database. So drop table, if it exists, ClutterBase, that will just delete any existing stuff there, create the table. And what we can do is we can basically pipe the output of this directly into SQLite, so it takes input on stood in, and then that will write it into a new database called cluttertest.db. If it exists, obviously we drop the table anyway, so it just recreates the data. And then I've got the add to database script that we developed, and I basically just call it multiple times. I could most probably tidy that up a bit more with some arrays, but for now that's fine. And if we run this, so if I just remove the cluttertest.db from there, just to show it in action. So if we run the create testdb, that runs off, and you can see that it's there. If we do SQLite cluttertest.db, select name from ClutterBase, you can see there's all the names that are in there. So it works nicely. We can generate our data. We don't have to basically store this larger file. It's not actually that big at the moment. It's only 2.4 meg, but we don't want to put big things which are going to change into version control. So the main reason that's there is basically so that we can generate the data as and when we need it. What I've also now generated is a script here. What I'll do is I'll run it and demonstrate it first. So if I put the script in here, you can see it's just fired up a little dialog here called ClutterBase, and if I click on load database, we can search and find the database I've just created there, load it in, and you can see now we've actually got our entire database of all of our meshes and things stored in there, so we can visualize it, see what's going on. And if we want to load one, at the moment I've just got it, so you just double click and you can see it just imports the mesh for us. So I can go in and load in a few bits and pieces there into my scene just by clicking in all the assets. I very just sort of simply group things at the moment by when I create them, so you can see each one's got its own little group, but makes life easier when you want to just import stuff, move it around, get all your layouts and so on. So it works nicely. The other advantage of this, and I'll demonstrate this first, is this is me remoting into one of the lab machines. All I've done is copied that ClutterBase that I've just created across. If I just load that in now, so this is called clutterbase.db. So I should load that database in here now, and you can see exactly the same thing on Linux. It's exactly the same file. We copy one file, and this is the advantage, that if you're working on projects, want to take stuff home, once you've generated your database, that's the only thing that you need to create and work in, so you can work across machines. This should work under Windows as well. At the moment you can see it's Mac and Linux. I haven't generated a Windows test yet, but I think it should work fine on Windows. I'll do that as part of the next process. So now we know that it's portable, which is one of the design goals. Later on we're going to look at taking this and now getting it into Houdini and maybe some other DCCs, but that's one of the first big things that we wanted to test, is to make sure this worked. So the script is relatively simple. It's using PySide 2, which is the Maya Python the MyQt of choice for Python. So we've got some imports here. I've got OpenMaya UI commands. Actually, a lot of this I'm mostly using, and I will tidy it up. This was a very quick cut and paste to get it working, so it needs a bit of tidying up here. This is key, get main window. This returns the Maya main window. So this function is called and it basically converts the Maya main window into a window that we can then parent our dialog to. So this is quite important of when we get there. I'll skip the image data model class at the moment. This is our dialog class. So this inherits from Qt QDialog, and basically the parent is the main window. That's the key here. So we call that get main window. That makes the dialog have the parent of the Maya main window. So when we close it, Maya knows about it and it can recreate it and so on. So we're adding that to the management of Maya. I've made this bit of code here just to call the parent constructor. This will take into account that this should work with older versions of Maya. We most probably don't really need to use older versions of Maya anymore. So I will most probably later on make this Python 3 only. In fact, this is Python 3 only for some of the other things I'm doing. Next, create the window, create a grid layout, add the widgets to it. At the moment, I'm using two widgets. I've got the button for loading the database, and I've got this, so that's the button there. And I've got this table view. Now, a table view uses the model view paradigm. So we have to build a data model which will basically have all the data from the database in it. And we're going to use all of Qt's built-in SQL data to do that. So there's two functions that happen here. Load database is when the button's pressed, pops up a file dialog, creates a QSQLite database connection, sets the name of the database, opens it. So that happens when the dialog, when we click on load, choose the file. It then checks to make sure that this is a valid ClutterBase. It does that by just seeing if it's got the correct table in there. So that's all that's doing. If it does, then we create this, what's called an image data model. So this is a class which is an SQL query model. And basically what this will do, here's the class here. If the data is coming through is text, then it just returns that text. If the data coming through is column 3, 4, 5, or 6, this is the image data. So this is the PNGs that we've stored in the blobs. So what we have to do is to basically convert that into a QPix map, which is the image that's going to be displayed in there. So it's a little bit of extra work there that we need with this data model. And then when we double click on any of the grids, so this was again quick proof of concept, we call the load mesh. And what that does is it runs a query. So it says select mesh data and file type from ClutterBase, where the ID is the ID of the one that was clicked, the row that was clicked. Later on, we might be able to select multiples and do other work and import more than one and so on. But for now, I just wanted it to work to show it as proof of concept. So we run this query to basically grab the mesh data. So in fact, I've got two queries there. So that's the wrong one there. It's here. Select mesh type file name from ClutterBase where ID equals mesh ID. That one can actually go now, so I'll get rid of that. If that query is successful, then we grab the mesh data and the mesh type, which are the two elements that we need. And then I create a temporary directory. So I'm using temporary directory here in a with clause. So basically that will delete all the data afterwards. And what we'll do is we extract and save that mesh that we stored previously into the temporary directory. Then if it's an OBJ, then it just imports normally. If it's USD, then we have to do USD import. If it's FBX, we have to do FBX import. We'll sort of change all of this if we add more mesh types and things like that. So I might tidy this up a bit better. So USD import, for example, is the minus, the type flag is for USD import. The FBX is for FBX, OBJ is for OBJ, as you can see there. And we basically import. The only other thing we do is we've got a group name there. Most we're going to have options for setting what we call the groups and various other things like that. And we're going to have more advanced queries and other things. So I'm really quite pleased with that. It seems to be working particularly well. We can just, if I just re-show the dialog, grab that line of code there. Dialog's been created, we can just call show again, and it should show it. So it appears to have disappeared. There it is. Oh no, that's the Linux version. Where's my dialog? No machine. There it is. Some of the issues you have with Windows, sometimes they go, it's hidden, I couldn't see it. So yeah, it works really well. I'm quite pleased with how this works. We'll add a better interface, the ability to load new dialogues, some options for various bits and pieces, how it's all going to work and so on. But as a proof of concept, this definitely, as you can see, works well. And it's basically everything we need. And that ability to transport the one file across and then just use these scripts is really good. So next steps, Houdini. I think for now I'm going to do my own Houdini. Then I want an interface to insert meshes into an existing database, and maybe a standalone app to do various bits and pieces as well. So this will all be written in PyQt, because PyQt is the really useful way of doing it. And I'm going to create a branch as a snapshot of where we've got to here, because this is going to change rather a lot. So it's good to have this as a snapshot going forward. So I'll work on this again for next week. It's nearly ready to put into production.